Observe the given figure and use it to answer the given questions. Label A, B, C, D, E, F, G, H, K, J and M. Draw the perpendicular line EH to pass through the center, O of the circle. Join line OK and OD, respectively. Line OK equals the radius, R of the inscribed circle. Line EH and OD are angular bisectors, respectively. For area of the circle, equate pi times the square of r and 36 times pi so that pi cancel out. Find the square root of the equation to give that r equals to 6 centimeters. We need to find the length of line DE and DF respectively. By trigonometric identity, the ratio of line OK to line DK equals to tan 18 degrees. Cross-multiply it and solve. For line DK, call the result equation 1. And also, the ratio of line OK to line KE equals to tan 54 degrees. Cross-multiply and solve for line KE. Replace OK and KE in the equation of line DE. We have after substitution that length of line DE equals to 22.825356391 centimeters, which we call equation 3. Also, line DF equals the sum of line DH and FH, as details are shown on the screen. Since line EH bisect line DF, line DH equals line FH, and by solving for the length of line DF, we have that DF equals to 36.932202446 centimeters. For question I, area of the blue rectangle DFJM equals length DF times length FJ, which is equals to 1846.6101223 square centimeters after substituting values obtained. Therefore, the required area of the blue triangle equals 1850 square centimeters to 3 significant figures. For question 2, join line AF and let the length of the regular pentagon be y. Using cosine rule, we find that the square of line AF equals the sum of the square of line AG and GF minus 2 times line AG and GF and cosine 108 degrees. Substitute values obtained. After substituting the values obtained and simplifying in the equation of the square of length of line AF, we have a new equation for the square of line AF which we called equation 4. But, line A, j equals line B, m which is equals to y minus line m j all divided by 2 for line m j equals to 36.932202446 centimeters. This implies that line A, j equals y minus line m j all divided by 2. Consider triangle AJF using Pythagoras theorem. The square of AF equals the sum of the square of AJ and JF. Substitute values obtained. After substituting values obtained, for the square of line AF and line AJ and line JF, multiply the equation by 4 to clear fraction, combine like terms. Arrange terms in one side of equation and simplify, we obtain the result shown on the screen. Then, y equals to negative b plus or minus the square root of b square minus 4 times a times c all divided by 2 times a. Use general quadratic formula, where a equals 9.47213592 centimeters, b equals negative 165.16583 centimeters and C equals negative 9,279.99983 centimeters. Substitute in the formula of equation of y. Simplify and we have that. Y equals 165.16583 plus or minus the square root of 378,885.43232 all divided by 18.944271884. Simplify further and we have that. Y equals 41.2104793 centimeters or y equals negative 23.77345914 centimeters. Thus, y is not equals to negative 23.77345914 centimeters. As length measuration cannot have a negative value. Hence, y equals to 41.2104793 centimeters, which is equals to the side length of the given regular pentagon. Reconstruct the regular pentagon and label the opposite two sides of the triangle as U. These inscribed triangles are congruent, each with apex angle equals to 72 degrees and base angles of 54 degrees. Using sine rule, the ratio of y to sin 72 degrees equals to the ratio of u to sin 54 degrees. Cross-multiply and solve for u. Make U the subject of the formula and substitute value of y, we have that U equals to 35.0557279 centimeters after simplification. Area of the regular pentagon equals 5 times the square of U times sine 72 degrees all divided by 2. Which is equals to 2,921.3930454 centimeter square. Thus, let D be the area of the regular pentagon not enclosed by the inscribed shapes. D equals the area of the pentagon minus the sum of the areas of the circle and the rectangle, which after substituting values, simplified to or equals to 961.68558 centimeter square. Hence, D equals 961.68558 centimeter square. Therefore, the area of the regular pentagon not enclosed by the inscribed shapes is equals to 962 centimeter square to 3 significant figures.